Hey guys, it's Miss Martinez. We're looking at the third section in Chapter 9, Adding and Subtracting Rational Expressions. As a student, by the end of this video, I hope that you will be able to add and subtract rational expressions, simplify complex rational expressions that contain sums or differences, and define the harmonic mean and apply it to solve real-world problems. So let's get started. Want to go back to, I don't even know when you learned this kind of stuff. Before middle school, like 6th grade, I think. It's been a while, so let's refresh our memories here. We want to simplify, and in this first one, we're adding two fractions. And here you can just add the numerators because the denominators are the same. That's kind of the rule for adding and subtracting fractions. You can only add and subtract them if the denominators are the same, which means you're left with 6/9, and that can simplify to 2/3. That would be the final answer. Now number 2 is not one that you can just swiftly add because your denominators are different. This requires you to multiply both of your fractions by a number. Now, I want you to look here. 3 over 3 is really just 1, and 5 over 5 is really just 1 if you simplify. But you're multiplying them so that what you have as a result is the same expression but with a common denominator in each. That means you're going to have 6/15 and 5/15. If you simplified, that would be 2/5 and 1/3. But now they are in kind of like the same. It's like if you wanted to add meters and feet, well, you would want to convert them to be the same to be able to combine them. Now we're not working with like apples and oranges, we're working with the same thing, 15ths. So 6 and 5, that's going to be added together. That is 11/15ths, and you can't simplify that anymore. This last one is subtraction, and you're looking for a number to multiply each of those by so that you have the same denominator. That would be 5 and 3, because if you multiply 18 by 5, it's 90, and if you multiply 30 by 3, it's also 90. In the numerator, you'll have 55 and 21. You'll take the difference of the numerators, and that's 34/90ths, which if you divide each of those by 2, that is 17/45ths. All right, so that's just a brief review of adding and subtracting fractions. If you need more practice like this, feel free to ask me. I would love to give you some problems that you could practice with and get better at this. We're going to use that same idea here with the rational expressions. To add them, you have to have the same denominators, and in this case we do, which means you'll just add the numerators. Combining like terms, you have 4x minus 8 in the numerator, and that's over x minus 2. Now you should see that 4 and that 8 and recognize that there is a GCF there. There's a common factor you can pull out, and that is the 4. That'll result in 4 times x minus 2 on top, and that allows you to cancel some factors. The final answer is just 4. So when you add those two expressions, the result is 4. Not so obvious from the start, but quite a bit simpler at the end. Let's look at another one, another idea here, finding the least common multiple. This is something that I know in your SATs and ACT testing in the practice, this comes up a lot, so I hope that this helps you tremendously and in this lesson as well. We want to find the LCM. LCM stands for least common multiple, meaning the smallest common multiple for the two expressions. And to do that, you have to factor the expressions into their prime numbers and say how many multiples of each of those primes you have. So 27, it can't be divided by 2, but it can be divided by the prime number 3. It would be 3 times 9, and 9 can be factored into 3 and 3. So that is going to be 3 cubed. 3 cubed is 27 times a. So now it is factored into primes. Let's do similarly for 18. 18 is 2 times 9, and 9 is 3 times 3. So that would be 2 times 3 squared times a to the 4th times b. So all I've done is express my numbers in primes. Now we want to find the LCM. The least common multiple is found by taking the product of the highest power of each factor. So let's see here. What factors do they have in common? Well, the first one has 3 cubed and the second one has 3 squared. We want the larger of those. Circle the larger. The first one has an a and the second has an a to the 4th. So we need to circle the a to the 4th. And then I know they both don't have a 2, but we have to take the largest, so that would just be 2, and also the b. So the result would be 3 cubed, because that's the largest. 2 is the largest. There's only one of them. A to the 4th would be the largest factor with a, and b just to the first power is the largest power of b that is available. That reduces to 54 a to the 4th times b. That is the least common multiple that these two expressions have in common. Let's do another one like this. This next time we're looking at not just monomials, but some larger polynomials. Again, we're going to factor each expression. The first expression would be x times x minus 4. You just pull out the GCF. And the second expression, why don't you take a moment to try and factor that? Pause the video and try and factor it. All right, the two binomials that would result are x minus 2 and x minus 4. Now we're going to find the product of the highest power of each of these factors. So we have to include all the factors, just the highest amount. So we have an x factor, but only one. We have an x minus 4 in common, and each of them only has 1. And we have an x minus 2 in the second, so we'll include that as well. If you multiplied all of those together, that would result in x cubed minus 6x squared plus 8x. That would be the least common multiple for these expressions. And you might be wondering, why do I need to do this? Well, when we look at this next example, I'll show you precisely why. Here we want to add, but we don't have the same denominator. We need to create like denominators, and we don't want it to be more than is necessary. We just want the least common multiple in each of those denominators so that we can add the rational expressions. So we'll factor the denominators and find the least common that they have together. So take a moment to try and rewrite these in their factored form. All right, in factored form, you would have 5x over x plus 3 times x minus 2 and x plus 7 over x minus 2, x minus 2. Now, what would be the least common thing that they should have? You want them essentially to each have the same amount of each factor. So what is it that the first expression is missing? It needs another x minus 2. And that would be on top and bottom so that you're not changing anything. You're multiplying it by 1, but so that the denominators have that same factors. And the second one is missing an x plus 3, so you need to include that on top and bottom, like we did in the lesson opener with our just fractions. Now we'll multiply the top. And the last thing would be to go ahead and add the numerators, combining like terms, and factoring and kind of simplifying that would show you that you have 3 and in parentheses 2x squared plus 7. And you can condense that denominator just a little bit. It would be x minus 2 squared. And it is perfectly okay to leave your answer in factored form like this. You don't have to go and multiply all the binomials in the denominator. You can leave it just like this. So that would be your final simplified answer. All right, here we're looking at subtraction. So we want to create like denominators. They look a lot the same. If we rearrange that second one, we see that the signs are just kind of like flip-flopped. And we did an example like this together in class. If you wanted to make that second one look like the first, you would just multiply it on top and bottom by -1. And then you would have the exact same denominator. Now we can go ahead and simplify and do the subtraction in the numerator, making sure, you'll see, making sure that I subtract every term in that second expression there. So that would be 5x plus 3x because it's minus a negative. And 4 minus 1 gives me that 3. And I can't do anything to simplify that. That is my final answer. All right, now I want to talk to you about what a harmonic mean is and contrast that with arithmetic means. Arithmetic means, although you may not have heard them called that, you've worked with them more in the past. So let's talk about the difference here. The scenario when you have the same time and the scenario when what you're given is the same distance. Average speed is total distance divided by total time. That's how you figure out your average speed. If you were working with the same time in, let's say, two different trips, then the total time would be the number of miles for the first trip plus the number of miles for the second trip, and it would be over the total time, which is 1 hour and 1 hour. Okay, if you're working with like a 2-day trip, where the first day you went 30 miles in an hour, and on the second day you went 60 miles in 1 hour. That would mean you're looking at 90 miles divided by 2 hours, which is 45 miles per hour. So the average speed on this 2-day trip would be 45 miles per hour. This is called the arithmetic mean. The arithmetic mean is where you take your two distances and divide it by your time. Now let's contrast that with the scenario where your distance, the distance you went each time, like, was the same, but it took a different amount of time. So maybe you went 60 miles on the first day and it took you 2 hours, and then you went 60 miles on the second day, but it only took you an hour. To find your average speed, you would add them and divide by 3, because 2 and 1 is 3, and that gives you 40 miles per hour. It's different. It's different depending on the distance you went and the time you went. So when you're working with the same distances, that is a harmonic mean. And the formula is your total distance divided by the reciprocal of your 2 times. Now I'm going to show you here that that is in fact, you could in fact justify that that is what we did and what we could use to find in the scenario above that 40 miles an hour. I'm actually going to do that with you all in class so that I can answer your questions, because it's a proof, and so it is a little bit more rigorous of a definition than I want to just put in our video. So that is the difference between arithmetic means and harmonic means. Arithmetic means you're working with the same time and different distances. Harmonic means you're working with the same distances but different times. And that's all. Have a wonderful rest of your day, and I'll see you guys soon.